This is the ECE 423 Cadence Tutorial, Department of Electrical and Computer Engineering, Southern Illinois University at Carbondale. Chapter 3, Spectre Simulation. Now that we have our inverter symbol in place, now we can create a schematic using that symbol that we can use to do our testing with. So first, what we need to do from the library manager is create a new cell view, file, new cell view, and we will call this cell inverter_sim. And it's a schematic. Press OK. And now we'll start adding our elements onto here. So we will create an instance, and we want to use the symbol for the inverter we just created. So we will go into our ECE 423 directory, we'll pick inverter, and we'll use the symbol, and we will close and hide, and we will put it into place, and then we will hit the escape key to stop the operation. Now we need to add all of our sources and such. So first, let's create an instance, and we will add our VDD power supply. So we will browse, and we will go to the analog lib. And we will choose a VDC symbol. We will close. We know we want this to be named VDD, and we want a voltage of 1. Please note that you only enter the numeric value. The system will fill in the units, the type of units for the value in automatically. So once we've done that, we will hit the hide button, and we will put it in place, and click. And we will escape to stop. Next, we will add our VDC for our input. So we will create an instance in an analog lib. A V pulse wave, a symbol. Close this. We will call this input, and our voltage 1 will be 1, voltage 2 will be 0. We have a delay time of 0. We have a rise time of 10 picoseconds. We have a fall time of 10 picoseconds. We have a period of 2 nanoseconds. And we have a pulse width of 1 nanosecond. So once we're done, we'll hit the hide button, and we'll put it into place. And click to set it, and escape to stop. Next, we will add some wires, create wire, and we will connect our elements together. We will add ground, from the analog lib, the G and D cell, symbol, close, hide. I'm going to place one underneath the input source at the VSS terminal and at the bottom of our VDD, and hit the escape to be done. Then we need to add an output pin, create pin out, type output, hide, put it in place, hit the escape key, and we'll do check and save. And we will verify, save with no errors and no warnings. So once we have that in place, we will launch our ADEL window to see the output. So from here, we need to go into setup, set up our simulator directory host. Should be Spectre /simulation, your home directory /simulation. Press OK. We need to go setup, model libraries. We need to add the model library. It's underneath the models directory, underneath Spectre, and it's the GPDK 045.scs. And press open, and we want the SS slow section, and press OK. Now we need to set up our DC analysis. So we need to go to Analysis, choose, we will choose DC, and we want to do a component parameter. So click component parameter, then select component, and from our inverter sim, we want to select our input voltage. And for component parameter, we select DC and press OK. And let's go back to our choose analysis window, and we should see the name of the component and the parameter name DC, and we will do a start stop. We will start at 0 and we will stop at 1. And we can press the OK button. Now we need to choose what we want to, the points we want to show on our graphs. So we need to go to the ADL window. We see outputs, to be plotted. Select on schematic. And on the schematic, we need to click the wire associated with the output, and then we'll click the wire associated with the input. And then we go back to the ADL window, and we will see they've been added here. From here, we can run our simulation by pressing the little green sideways triangle inside the circle. And see our graph. We have our output and we have our input. And we close this for now. If we just want to show one of those on here, we can choose. If we just want to see the output plot, we can unclick the plot check mark here, and we can go to the little graph here. Since we're not going to rerun the analysis, we're just going to show the previous analysis again with the one plot, and we will see the output wave. We can also show both plots on the same window, and we can split them apart so that we see them on the same window but separately. So now we're going to do a transient analysis. So we go to Analysis, we'll choose Transient Analysis, and we will do it for 20 nanoseconds, and we will enable it. Press the OK button, and we will uncheck the Enable DC analysis so that we won't run both at the same time. And we will hit our little triangle inside the green circle to rerun the analysis. And we will see our input and output plots on top of each other, and we just click this to separate the two, and now we'll see our input and our output separately.